Hello and welcome to lesson 5.4 for Math 10C. Today we're going to talk about something very important. We're going to talk about something called slope-intercept form. What slope-intercept form is the way of writing equations, and that way we'll follow this formula, which we will call slope-intercept form. To start things off, we're just going to do some practice graphing. So to graph things, hopefully you've done that in the previous unit and you've gotten good at it. I know that's probably hard to learn with the online COVID learning, but hopefully you did your best to figure out your calculator. If you did, I want you to practice graphing these 8 graphs on your window. When you click window on your calculator, it'll give you your x minimum, x maximum, x scale, stuff like that. So it goes x min, max, x scale, and then y min, y max, y scale. When you practice graphing all these, for your minimum, you want -10. For your maximum, you want +10. And your scale, you want 1. Minimum, -10. Maximum, +10. Scale, 1. So go ahead, try to graph all those things. You should get lines that look somewhat similar to mine. So I've drawn all the lines there. We got some curvy lines, some straight lines, some really weird looking lines, some broken lines. Try your best to see if you can get those graphs. Once you have those graphs, you can unpause the video and then we'll go down to this part, start answering some questions. So the first part says list the equations of the graphs in the appropriate row. Linear and nonlinear. Linear means making a straight line, right? Line, linear. So if we look at these equations up here, the ones that are linear would be y equals 3x plus 1. The first one, this one right here, made a line. The second one made a line. So y equals -2x plus 3. Also made a straight line. The third one did not make a line, so we call that nonlinear. The fourth one did not make a line, we call that nonlinear, right? Those are curvy. There's lines there, but they're not straight lines. They're curvy, so we call them nonlinear. This fifth graph made really weird looking broken line. We call that nonlinear. This one over here, even with the fraction, created a straight line, so we'll count that as being linear. That was 1/2x minus 2. The second last one here makes a straight line. That's a nice simple one, just y equals 4x. And the very last one did not make a line. We call that nonlinear. Well, it made a line. It did not make a straight line. The second part of this question says to state all the nonlinear lines. So the nonlinear lines were the ones we already listed, which is -x cubed plus 1. The other one is y equals x squared minus 3, I believe. The other nonlinear was y equals 1/x. And the last linear equals y equals 2x. Now, if we look at these lists of linear lines and nonlinear lines, we should hopefully notice a trend. And that trend has to do with the variable x and the exponent on that variable x. So if you look at all the linear equations, they all have an x value, and they all have exponents of 1. If you look at the nonlinear cases all have different exponents. This is technically an exponent of -1, right? And the last one actually has x as the exponent. So it doesn't have x as just a regular variable that we're used to seeing. So these are non-exponent 1. This will give us our first kind of general rule of the day. And that first general rule is that to make a straight line, it must have x to the power of 1 and nothing else. No other exponents. No other x to the power of anything. I'm just going to put a question mark up there. So that's our first kind of rule. To make a linear equation, you need to have an x to the power of 1, and you can't have anything crazy after that. So you can't have like to the power of 3s, you can't have x squareds, you can't have x in the denominator, you can't have negative exponents, you can't have x as the exponent. Right? The only thing that it makes a straight line for us is when you have x to the power of 1 and nothing else for your x variable. Cool. A linear equation is an equation that is in the form y equals mx+b. So all linear equations can be rewritten like that. Can be written in that form, where m and b are numbers. Right? So that's what this is saying right here. M and b are numbers. And they can be any kind of number, right? That's why it says R. That means it's a real number. So it could be a decimal, negative, positive, fraction, anything. M and B can be anything you want. Cool. Warm-up number 2. Investigating M and B. So over here we have a nice little graph. The graph is of this equation. Y equals 2 over 3x minus 1. We're going to look at that graph, and we're going to notice it has 2 points given to us, point A and B, and we're going to investigate a little bit. So use the sketch at points A and B to find the slope and y-intercept of this line. Let's find the slope first. So the slope of this line, AB, equals rise over run. From A to B, the rise is 1, 2. The run is 1, 2, 3. So the slope is 2 over 3. The y-intercept of this line, if we're looking at this, the y-intercept is where it crosses the y-axis. This is the y-axis. It crosses right here. So that's my y-intercept. It's at -1. Cool. Those values we just found, when we look at the equation, you'll notice they show up. So that's my equation. Look at this. That's my slope value. And that is my y-intercept value. And that's not a coincidence. So whenever you have an equation that creates a slope, that creates a straight line, it's going to look like this. Y equals mx plus b. This follows that. Right? 2 over 3x plus b. Minus 1. Right? That followed that formula. And we just realized that the first number they gave me was the slope, and the second number they gave me was the y-intercept, which means we can come back to this formula and we can realize m equals the slope and b equals the y-intercept. That means when I'm given an equation and I don't have the picture, I just have the equation, I can figure what the slope is and what the y-intercept is just by looking at the values of the equation. M will be my slope value, B will be my y-intercept value. Sometimes it can be confusing to start, and then we'll do a few more questions, and you'll be like, oh, I see, it's just a pattern. Y equals mx plus b, m is the slope, b is the y-intercept. We've got 2 graphs here. So the first graph I'll do in blue. So we got a graph right here. So that line is this equation right here. And the second line I'll do in red. So this equation right here is this one right here. Awesome. If I'm looking at the blue line and I want to calculate the slope, I take 2 points and I do rise over run. So I'm going to do from here, I'm going to go rise, 1, 2, run, 1. The slope is 2 over 1, which we know equals just 2. If I'm looking at the blue line, the y-intercept is right there, and that value is +1. If I look at the equation is in the form y equals mx plus b. And we notice that m is the slope of 2 and b is the y-intercept of 1. So if I look at the red line, I don't even need to look at the graph, and I can tell you what the slope and what the y-intercept is. The slope will be my m value. The m value is negative 5 over 2. And the y-intercept is the b value. In this case, the b value is negative 3. So this red line should have a y-intercept of negative 3. It does. And a slope of negative 5 over 2. 1, 2, 3, 4, 5. 1, 2. Negative 5 over 2. It works. We now can officially say that y equals mx plus b can tell me the slope and the y-intercept. Hence, we call this slope y-intercept form. Very original name, right? It tells us the slope and the y-intercept, so they called it slope y-intercept form. Awesome. Let's see how this works. So, Hashi used a graphing calculator to graph the linear equation 2y equals 5x plus 8. The graph is shown on the grid. Use the sketch to determine the slope and the y-intercept of the graph. Explain why the slope is not 5 and the y-intercept is not 8. Okay, so he graphed this. Graph this equation right here. When he graphed it, he got this. If we look and we calculate this, the slope equals 1, 2, 1, 2, 3, 4, 5. The slope is 5 over 2. And the y-intercept, if I look at this graph, is up here at 1, 2, 3, 4. Y-intercept's at 4. We just said that when you graph a linear equation, the value in front of the x, the 5, should have been the slope. And the value over here by itself, the b value, should have been the y-intercept. But then when we check, that actually didn't work, right? So if we look at these two values, they're not 5 and 8. We got 5 over 2 and we got 4 as our slope and our y-intercept values. So why didn't our trick of just looking at the values work? The reason why it didn't work, he graphed this. 2y equals 5x plus 8. This is not slope-intercept form. The reason it's not y-intercept form, slope y-intercept form, is slope y-intercept form is this, y equals mx plus b. Notice that there should be no number in front of the y. If there is a number in front of the y, you need to move it to the other side. The way that you move it to the other side is by dividing that number to the other numbers on the right. So we would divide every number by 2. And that would give me my proper slope-intercept form of 5 over 2x plus 4, which gives us our real slope and our real y-intercept. So I think the trick here is to be very careful when you're using slope y-intercept form to do quick answers for slope, because sometimes things look like they're in slope intercept form and they're not. Slope intercept form has to have no number in front of the y variable. There could be no number here. Right? Just the letter y. Okay. Slope intercept form, we already talked about that. That just kind of sums up what we did. So if we look at these questions right here, it says determine, so that means find the slope and the y-intercept of the linear equations below. Looking at this one, to figure out the slope and y-intercept simple, we need to make sure our equation is in y equals mx plus b form. This one is in y equals mx plus b form. M is my slope, so my slope is 3. B is my y-intercept. My y-intercept is at 2. Easy as pie. So they give you an equation. It's in slope-intercept form. Match up where the m is, match up where the b is, and you know your slope and you know your y-intercept. If we look at the second question is in slope-intercept form. It's just a little bit weird. Slope-intercept form normally looks like this, mx plus b. But if we look, things aren't in the right spot. My mx is actually right here, and my b is actually right here. So what they've done is they've just rearranged it and they've made it b plus mx. But the rules are still the same. The m value will be my slope. So my slope here is negative 2 over 3 because that's the m value. My y-intercept in this question is my b value. This time it was written first. My b value is 7. The best way to make sure you don't fall for any tricks like that when they rearrange it, the number that is the coefficient on your x value should always be m. So if we're looking at this, here's my x value. The number that is the coefficient should always be my slope. The number that's the constant, that means by itself, should always be your y-intercept. Awesome. If we look at C, C is not in slope-intercept form. Slope-intercept form should have no value in front of y. This one does. It has a 6. So we need to divide that 6 to the other side to create real slope-intercept form, which would be 8 over 6x plus 1 over 6. Now I'm in slope-intercept form because y is all by itself. My m value, or the value in front of the x, tells me my slope. So slope in this case is 8 over 6. And my y-intercept in this case is the value by itself, is 1 over 6. Cool. Let's talk about that slope for a second. Just a reminder that slopes can be rewritten in different ways. So for instance, 8 over 6 can be reduced. I could divide both the top and the bottom by 2 to become 4 over 3. Those are the same slope. They're equivalent fractions. I also could change it to a decimal to be 1.3 repeated. Those are all the same slope. So when you're doing a multiple choice test, just because the slope you have isn't one of the answers doesn't mean your answer's wrong. You might just have to find the equivalent fraction to your answer. The best way to do that is to either math frac in your calculator or just change all the answers to decimals and see which decimal works out for you. Wonderful. Graphing slope-intercept form. Probably the biggest perk of slope-intercept form is the graphing part of it, because it makes it easy to graph lines. So if we look at this question right here, it says, consider the equation y equals 2x minus 5. The first thing I'm going to notice is, hey, that is mx plus b form. That means I know the slope equals 2, and I know the y-intercept equals negative 5. Easy. Now we're going to graph it. To graph things, I always say that you need a starting point, and y-intercepts provide a great starting point. So if I want to graph this equation, I need to draw my y-intercept of negative 5. That's going to be my starting point. The next thing I'm going to do is I'm going to use my slope as a map to the next point on my line. My slope always equals rise over run. In this case, they only gave us a rise. They never told us the run. We remember from previous lessons that when it's just the number 2, we always change that to be 2 over 1 to make it a fraction. I'm going to use that slope of 2 over 1 to get to the next point on my graph. So I started at negative 5. I'm going to rise 2, 1, 2, and I'm going to run 1 to right there. And I could keep doing that to keep getting points. Go up 2, 1, 2, run 1. Up 2, 1, 2, run 1. And I could keep finding points over and over again. And you'll notice that I'm making a straight line pattern. To graph this, all I need to do is connect the dots like that. And I have created my graph of y equals 2x minus 5. It's probably the biggest perk of slope-intercept form is being able to quickly graph things because you know where you should start on your graph and you know how to move along the line, how to get to one point to the next. If you want to check to see if that's right, try graphing in your calculator and you should get the exact same line we just did. Awesome. This last question, I want you to just try graphing it on your own. Okay, so go ahead, pause the video, try to graph it. Awesome. If you did that, your y-intercept is -6. That's going to be my starting point. My slope is 2 over 3. So if I go up 2, 1, 2, and over 3, 1, 2, 3, I get the next point in line right there. And I could do that a couple more times if I wanted. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And I get this nice graph right here. Awesome. If I looked at this graph, I could tell you what the x-intercept is. Looking at this graph, I could look at the x-intercept and say, hey, the x-intercept is 9. To algebraically prove that, you need to make y equal 0 and then get x by itself, right? That's what x-intercept means. It means make y 0. So if I had 0 equals 2 over 3x minus 6, I could then solve the x-intercept algebraically by moving the 6 to the other side. Then multiplying by 3 to the other side. And then dividing by 2. To get 9 equals x, which I proved right here. So once you draw it, if you don't like doing algebra, you could graph things and then find y-intercepts and x-intercepts really easy just by using the graphs rather than having to do the algebra all the time. The algebra I do think is the best way moving forward to be good at just because it's good practice for algebra skills because you need to be good at algebra in future math classes. Awesome. We already graphed that line, so we already know we could just connect the x-intercept, y-intercept to make that graph. You could verify that by graphing in your calculator. Awesome. That is y equals mx plus b or slope y-intercept form. Hope you enjoyed the lesson. Take care of yourselves.